Done. Hello. Due to some technical problems, we were not in the state to continue the class. Now again, I'm going to start it, and I'm just going to try to give you the next set of the information. I'm just going to guide you. We were discussing the topic electrochemistry. Next time I will try that we will upload the video, premiere view. We will try for that. Electrochemical cells we were studying there. Electrochemical cell, I just taught you that it is the device where the conversion of the electrical energy and the chemical energy takes place, right? The electrical energy is converted into the chemical energy and chemical energy is converted into the electrical energy. On the basis of this, two categories were divided. One was the galvanic cell and the second was the electrolytic cell, right? Galvanic cell, the cell that converts chemical energy into the electrical energy. That means by a chemical reaction, electric current is produced, and this reaction is a redox reaction, spontaneous redox reaction, right? And the second type of the cell is the electrolytic cell. That means where the electrolysis takes place. And you all know that electrolysis word means the dissociation of the ionic compound or the electrolyte by the allowing electric current to pass through one solution. If a chemical change takes place, like if I take this example of sodium chloride, I take the solution of the sodium chloride and, right, on passing current, it divides into the sodium plus and Cl minus ions, right? So what is you are going to see here? What thing takes place here? A chemical reaction is carried out by the influence of the electric current, right? And this is called the electrolytic cell. The device, right, the equipment that we use for this is the electrolytic cell. So two types of the cells are there. One is the galvanic cell and the second is the electrolytic cell. Here, if I come to the galvanic cell, there are two types of the cells again. Chemical cell and the second is the concentration cell. In this, what happens? Only the chemical change takes place, right? By the chemical reaction, the electric current is produced, right? The chemical reaction takes place, and in this chemical reaction, one species undergo the oxidation, other species undergo the reduction, the transfer of electrons take place, electrons move from one place to another, and because of that, what happens? The electric current is produced, but the substance does not move. The concentration remains constant. There is no movement of the mass, right? The substance does not move from one place to another, right? So whatever the concentration you are going to take in the beginning, the same will remain, right? But here, what happens? The concentration changes, and this change in the concentration may be of both the electrolytic solution or the electrodes. Both the things are possible here, right? So here basically I taught you what is the electrochemical cell. The cell, the apparatus, the device, the setup in which either the electrical energy convert into the chemical energy or the vice versa. By the chemical change, the electric current is produced is called the electrochemical cell. Two types of cells are there. Galvanic, chemical energy is converted into the electrical energy. Electrolytic cell, electrical energy is converted into the chemical energy, right? And here galvanic cell, two types of the cells are there. Chemical cell, that means only the chemical reaction takes place, but there is absolutely no change in the concentration, neither of the electrolyte nor of the electrodes. Here the concentration changes, right? And this change may be in the concentration of either the electrode or the concentration of the electrolyte. Now I am coming that what chemical reaction takes place here. In all the different types of the cell, whatever the cell is there, the reaction, the chemical reaction that takes place is the redox reaction, right? You are familiar with the word redox reaction. Just I am going to give you some examples. The word redox reaction, class 11, a complete chapter is there of the redox reaction, and this is one of the favorite chapter of the students also, because it is very small one, right? Redox, here two reactions are there. First one is the reduction, and the second term is here oxidation. The chemical reaction in which both the reduction as well as oxidation takes place, right? Simultaneously, both the things are taking place, reduction as well as the oxidation. Before I just summarize it, I just want to know that you know about the oxidation or reduction or not. Oxidation and reduction, these are the two different types of the reactions. The chemical reaction, right? The very simple one definition that was earlier used, especially in the lower classes we study it, addition of oxygen. This is called the oxidation. It is just, reduction is just opposite. Whenever you are going to study the oxidation and reduction, please learn one type of the reaction only, and then the second will be inverse of that, just opposite of that. If oxygen is added here, that means definitely it will be removing from the here, right? So removal of the oxygen. This is called the reduction, right? The another way, the very simple example you can see here, C plus O2, CO2. This is all the conversion reactions are basically the oxidation reactions, right? One example I can take here, H2O2, hydrogen peroxide, right? In this, what happens? Water and oxygen is being produced here. So what you see here, the oxygen is being removed. So both the things, addition of the oxygen is called oxidation, and the removal of oxygen is called reduction. The second way is in the terms of hydrogen, right? Removal of hydrogen. Just please see here, it is the removal of hydrogen. This is called the oxidation, and here the addition of hydrogen. Right, I am taking one example here, CH2 double bond CH2. Now it undergoes the hydrogenation reaction, and this forms the CH3. This is the example of the reduction, very commonly. But you all know that now the chemistry is discussed in the terms of the electron, right? In the terms of electron, it is discussed. So here, the oxidation is also defined in the terms of the electron. Oxidation is oil. Oxygen is lost, right? What it is? It is the chemical reaction in which the electron is lost. This is the most important concept. This is the most important definition of the oxidation and the reduction, right? The chemical reaction in which electron is lost, the process of losing of the electron, right? This is called the oxidation, right? For example, sodium, it loses its electron, it forms the Na plus, right? This is one example of the oxidation reaction. The gain of electron, right, is the reduction, just inverse to that, right? The process of loss में जब रहता है, that means it is the oxidation and gain process, right? This is called ridge. Reduction, the reaction in which it is electron is gained, the reaction in which the electron is lost. Take the example of Cl. It takes the electron and this forms the Cl minus. And in the last, I just want to give you the thumb rule how to check the oxidation or reduction is going to take place. And this thumb rule is based on the one special term, oxidation number. The charge present on any of the atom in the compound form, in the molecule form, in the ion form, right? That charge, the amount of charge present, like here I can take the example of sodium. This is having the 1 unit of the positive charge. That means its oxidation number is +1. Here the sodium, it is having the 0 charge. It is in the element state and it is having the charge 0, right? So since it is having the 0 charge, its oxidation state is 0, right? So the oxidation number or the oxidation state, it is the ultimate clue, it is the ultimate method by which you can come to know whether oxidation is taking place or the reduction. The reaction in which there is an increment or the positive change in the oxidation number, right? That is called the oxidation, the chemical reaction in which the oxidation number or charge is increased positively. There is a positive change. It is the process of increment. That is the oxidation, right? What is here? Its charge is 0. Now its charge is +1. Now its oxidation state is changing 0 to +1, right? And this is a positive change, right? So this is a reaction that is to be defined as the oxidation on the basis of the oxidation number. Here the Cl again is in the atomic form, that means charge present is here 0, right? The 0 is the amount charge present here, right? And now here it is Cl minus. This 1 unit charge is its oxidation state. So what the change you can see here is taking place, it is changing from 0 to -1. Is it an increment? No. It's a decrease. It's a negative change. Always and always oxidation is accompanied with the positive change in the oxidation number, and the reduction always a decrease in the oxidation number. This may be, right, -1 to -2 also, right? That is also a decrease. +1 to 0, +2 to +1, that is also a decrease, right? This may be 0 to +1, +1 to +2. Another example I'm just going to take you here, and that is very commonly discussed in the cell, that is the CuSO4 plus Zn, that I have shown you in the beginning also, and I can again show you here what has happened. Now you can see I have earlier taken the solution of the copper sulfate. I added some granules of zinc. Now you all can see the granules has become brown. This brown is due to the accumulation of the copper here, right? That means from the copper sulfate, the copper has been displaced. What the reaction is here? Now it is ZnSO4 plus Cu. Now I am going to analyze it in the terms of oxidation and reduction. Here the copper, its charge is +2. Since you all know sulfate is -1, 2. How to find out this number, I will tell you in the next class. Right, zinc is here in the element form, the charge is 0. Now what you see, Zn is, if it is minus 2, that means definitely it must be plus 2. And the copper is 0. Any atom in the element state, always and always its oxidation state is 0. Right? So now what the change you are going to see here? Copper from plus 2 is changed to the copper 0. This is one change going to take place. The second, Zn is converted into Zn2 plus. It was earlier 0, now it is the plus 2. Two reactions are taking place here, right? Simultaneously. This is reduction, right? Plus 2 to 0. This is a negative change, and always negative change leads to the reduction. Here 0 to plus 2, a positive change, that means oxidation. And since both the reactions are taking place in the same container, this is a redox reaction. So this is the difference between the oxidation and reduction. When both the reactions take place simultaneously, this is called the redox reaction. And in all the different kind of the electrochemical cell, redox reaction takes place. In case of the electrolytic cell, a non-spontaneous. In case of the galvanic, it is a spontaneous. Next, we will learn in the next chapter. Thank you and keep learning.